Okay, today we're going to talk about processes. One of our course objectives is to understand processes in Unix. So today we're going to make an effort to understand processes in Unix. So everything that runs in Unix is a process. If you look at the /proc directory, which we haven't actually looked at before, all these numbers here are process IDs and information stored about those processes. So if we look at one of those, every process has this information stored about it on the disk. Why is it stored on the disk? Well, we only have one, maybe two, maybe four processors. But if we look at how many processes are running on our system, it's definitely way more than four. So what actually happens is your operating system will keep track of the processes, and it will switch processes in and out of the CPU based on some algorithm it uses to determine who gets to use the CPU and when. And so every process gets a little bit of CPU as needed. So the operating system is constantly switching between processes that are running. I put running in air quotes. Because they're not all running at the exact same time, so we don't have an infinite number of processors. So what it needs to do is it needs to save the information that the process needs when it removes it from the CPU. So a quick version of what happens is a process is running, the CPU needs to put another process on the processor, needs to do some processing for another process, so it needs to take pretty much a snapshot of what the current process is doing, so that when it puts that process back into the CPU, that process can take up where it left off. And in Unix Linux, that information is saved in the proc directory. So that's it for the proc directory. You probably won't ever really be going in there or doing anything in that directory unless you just want to go screw with some people and delete their proc directories and kill their processes that way. It's also a good way to screw up your system if you are accidentally deleting things you shouldn't be deleting. Good news is you have to be root to do that. You guys aren't root on my box, so that's not going to happen. So the processes, if we want to see the processes that are running on our system, we can use the ps command. Like all commands, I have my list of favorite options. For ps, I always use -ef because I want to see all the processes and a full listing of information about them. If you look up through here, this shows all the processes that are running. So how many processes do we have running? Oh, I don't know. Good thing we know a command that can count the number of lines for us. Word count, remember that one? Counts the number of lines. We have 56 processes running. Oh, do we know? We don't. We have 55 because this top line is a header line. It got counted as well. So we have 55 processes running on our system. The processes are identified by which user is running them. Almost everything's being run by root. This is SendMail. It gets a special user ID to run it. NTP, special user ID, dbus, whatever that is. And then I have some EC2 user processes. So those are my processes that I'm seeing as the EC2 user. If I want to see just my processes, I can just do PS, and it'll only show me my processes. I think I can do -F to see more information about them. Yeah, so I can see the full listing if I do PS-F. Shows me all my processes. You'll notice there's a PID and a PPID listed. Every process gets its own ID number. That's the PID. And every process has a parent. That's the PPID. The parent is the process that spawned your process. So if we're worried about process numbers, we can find out what our process numbers are by using the PS command and looking for our command. So I have let's take a step back for a minute. Processes, when you run a process at the shell prompt, when I say run a process, that's a command. Any command you run generates a process. What normally happens is your shell will fork a subshell and run that process. So your process doesn't actually run in the current process you're running. It starts its own process. So if we can look at our process ID Fortunately, there's a special share variable, $2 signs, to show you your process ID. So if we look at our process ID like that, we see my process ID is 4700, which I could already tell because my process ID says 4700. So that's my process ID. So when I run a command, it gets executed in a different shell. So if I was to run a different command to echo out my process ID, you would see it would be something other than 4700. I've actually written a little script, a very little script. Let me go to the right directory. I've actually written a little script to echo the process ID to demonstrate a couple different things. So it's called pid.sh. Essentially, it echoes $, which was that same command I just ran. So if I run pid.sh like this, I just ran, well, let's go run the command again. If I run it at the command line like this, it prints 4700. So if I put it inside a script to do the same thing, you might think it's going to say 4700. But what actually happens when you do this is your current shell spawns a subshell that runs the command. So this command is going to be run in a different shell. So now you see the process ID was different. And if I run it again, it's going to be different, and different, and different, and different. So by default, when you run a command in the shell, it runs that command in a subshell, and it waits for that shell to finish before it continues. So that's why you do not get control of your command back until it's done. So I've written another script called endless loop. This is going to demonstrate how it waits until the process is done. So if I run my endless loop script, well, let's look at my endless loop script first. Endless loop script essentially says, hey, set a variable to 1, I variable to 1, while 1, that means forever, essentially, do this thing. So I echo the incrementing number in the process ID, and then I increment I by 1 so I can get a full number. So let's run this command to demonstrate how my shell will wait. So the command's running, and my shell is waiting. My parent shell, even though it ran the command in a subshell, I don't have access to my parent shell in order to do any additional processing. To kill this program, you can type Control-C. Control-C killed it. It is dead. That process no longer exists. See, the process ID says 4760. If I do a PS and look for 4760, it's going to not exist. Nothing there, right? My grep command showed up, which happens all the time, but there was no process 4760 because I killed that process. All right, that was Control-C to kill the process. Something I see people do all the time that kind of is a pet peeve of mine is they hit Control-Z. Control-Z suspends the process. So this says stopped. It's suspended. The process still exists. The process number was 4763. Hopefully it'll show up. Yeah. So the process still exists. 4763 is still there. It's just suspended. There are two things you can do when a process is suspended. You can bring it back to the foreground to have it keep running by typing FG. Control-Z will suspend it again. You can put it into the background. This will cause it to keep running but give you control of your shell back. So right now the process is not running. It's suspended. It's waiting. When I type BG, it's going to move into the background and keep running. That didn't move into the background. Control-Z. Control-Z. Alright, so that didn't do what it's supposed to. Alright, so I killed that process. You couldn't see what I was typing. I typed kill 4763. So the process went to the background, but it was still displaying the output to my standard output of my previous shell. And I wasn't really expecting that to happen. So what we're going to do is we're going to run the command again, but redirect the output to dev null, which is a trash can. So now the command's running. Did the command run? I don't know. Oh, that was PS. I didn't want PS. I wanted to run my endless loop shell. Yeah. Redirect that into dev null. Now the process is running. We can't see it running because I'm redirecting the output. I don't have access to my shell because my shell is waiting. So Control Z suspended it. BG put it in the background. Now I have control of my shell again. If I type jobs, I can see that I have a job running. Has a process number. I can bring it back to the foreground. FG, right? I can Control Z to put it back in the. I can suspend it. BG to put it back in the background, and now it's still running. So I want to bring it back to the foreground. And I want to kill it with Control C. So Control Z suspends it. Foreground makes it take over your shell. Background will put the processing in the background, but you may still end up getting output displayed to your current shell. I wasn't expecting that. Running the background gives you access to your shell. So you can also run this command in the background from the command line by giving it an ampersand at the end. Ampersand pretty much means run this command in the background. So now it's running in the background, but we're getting the output again. So I want to bring it to the foreground and kill it. So I typed FG to bring it to the foreground and then Control C to kill it. So I'm going to run it again with redirecting it that way. Oh, that's not what I wanted. Control C killed it. Ampersand to run in the background. So it ran in the background. It reported to me the PID of the process, and it's running. If I do a PS, it shows me my processes. 4771, 4771, it gets reported as bash because it's basically a subshell that's running that command for me. Alright, so that was foreground and background. I'm going to kill that process. Kill that process that way. Another way you can kill the process is, oops, not the right command. Another way you can kill the process is with a process ID. I did that a minute ago, but didn't really talk about it. Kill the process ID 4775. That will kill the process. So right now, if I type jobs, you can see I have a job running. If I need to kill it, I can kill it by the process ID and run jobs again, and it shows me the job terminated. And now if I run jobs again, it shows nothing. So that will kill things with a process ID. If you are root on your own box at home and you have a process stuck, you can kill it that way. Sometimes when you need to kill processes, when you use kill to kill a process, it tries to kill gracefully and give it a chance to shut down. But sometimes you just want it to die. Kill doesn't work, so you can do kill -9 and the process ID. -9 means right now, die, I want you to go away. So there, if I do jobs, it's killed. So that was interesting. If you kill it without the -9, it says terminated. You kill it with the -9, it says killed. Cool. Didn't know that was going to happen. So that was that. Back to the subshell versus the current shell. Like I had said before, if you run the process like this, that runs in a subshell, right? 4770. Let's run the process. Here, let's echo $$ to get our current process ID. Our current process ID is 4700. If you run the command like this, then that's going to run in a subshell. If you want your command to run in the current shell, you can put a dot before your command, and that essentially says run in my current shell. So this will cause it to not run in a subshell. So there we see if I do it that way, I get 4700. So the dot means run in my current shell. Another program we might want to look at to see our processes is top. Top shows us our processes, CPU usage, how much is system, how much is idle, how much is user, amount of the CPU is waiting. If you're doing something I/O intensive, then the CPU has to wait for the I/O. It shows you number of processes running, number of processes, how many are running, how many are sleeping. Remember earlier I said you can't have more than one process using a CPU at any given time. So if you have a a one processor system, you're only going to have one running. The rest will be sleeping. Let's tell how long your system's been up, how many users are on, load average. That's the average of your CPU usage over the last minute, 5 minutes, 10 minutes or something. I don't know exactly what the times are, but those are 3 different time frames for CPU usage. And it shows how much memory you have, how much is used, how much is free, all that kind of stuff. So that's one way to look at your processor utilization. It moves around, putting the most CPU intensive tasks at the top. So as things start using more CPU, they'll show up in the chart and show that. One other thing I guess I'll mention, because it's in the chart and it might be interesting, is nice value. Nice kind of sets your process's niceness, whether it wants to hog the CPU or be kind with the CPU. So the process that has a lower nice value, I'm not sure. Is there a man page for that? Man nice. Run a program with modified scheduling priority. So niceness range from -20 to 19. So the higher the nice value, the least favorable the processing is. So you'll get less CPU cycles if you have a higher nice value. So if you're really nice and you're letting other people use the CPU, most of the time you're probably not going to bother with that. But I just thought I wanted to mention it since it was in the output of the top command. Our book has some information in Chapter 8 about processes, but we pretty much covered that and beyond in this podcast. So if you want to look a little bit about the PS command, a little bit about the kill command, and a little bit about the top command, you can look in Chapter 8 of our book for that stuff.